In this video we're going to talk about this topic and the skill involved with concurrent lines and looking at what these are and where they meet. Now, we've looked at when we intersect lines. So we've looked at if we've got a pair of lines, where do they intersect? Can we calculate that point? Concurrent lines bring in more than two lines. So concurrent lines look when we've got 3, 4, 5 or even more lines involved in a set. Now, we've said two straight lines can intersect at a single point. If 3 lines intersect at that same single point, these lines are said to be concurrent. That's the term we use for it. So if we look at this example here, at no single point do all 3 of these lines meet. Because of that, we can't say they're concurrent. But if we look at this example here, all 3 of these lines meet at this point right here in the middle. All 3 of them have the same point of intersection, so these lines are concurrent. Now, there's an easy way to prove or determine if any group of lines are concurrent. First thing we have to do is solve any pair of lines. So go back to the intersection of lines stuff that we did and find the point where those 2 lines meet. What we then have to do is take the solution we find and substitute it into the third. If it works, great. All 3 of them are concurrent, the point lies on all 3. If it doesn't, they're not. So the 3 lines aren't concurrent, so this is more the scenario we have got. Best way to demonstrate this, a few examples for you. First question is the following group of lines concurrent? So I've got 3 equations of straight lines here. 3x plus 2y minus 14 is 0, 2x minus 5y minus 3 is 0, and x plus 6y minus 10 is 0. Are these lines concurrent? Now, the first thing we have to do is pick a pair of these lines and solve them. Do yourself a favour and pick the easiest pair of lines. Now, this one here has an x in it, a singular x, so it's easier to scale up to one of these 2. So pick any pair, but make this one of them. So I'm going to pick these 2 at the end. So I'm going to say 2x minus 5y minus 3 equals 0, and x plus 6y minus 10 equals 0. Now, a couple of ways you can solve it, like we talked about in the intersection of lines. We could rearrange it, substitute in, treat them like simultaneous equations. I'm going to do that. So I'm going to treat them like simultaneous equations. I'm going to scale this bottom one up, multiply it by 2, and then subtract them. So I've got 2x minus 5y minus 3 is 0 for the first one. Second one tells me I've got 2x plus 12y minus 20 equals 0. What I'm then going to do is subtract the second from the first. So 2x minus 2x is nothing. Negative 5y minus 12y gives me negative 17y. And then negative 3 minus minus 20, negative 3 minus minus 20 becomes negative 3 plus 20, which is plus 17. And that equals 0. So negative 17y plus 17 is 0. Rearrange it, you get 17y is 17, y is equal to 1. What we then do is take the value of y and substitute it into one of these 2 equations. Don't substitute it into this one yet, because you're assuming it works then rather than proving. Substitute it into one of the 2 that we've worked with, and then after that we look at the third one. So I'm going to put it into this one here. So x plus 6y minus 10 is 0. So I get x plus 6y, so it's plus 6 minus 10. So it's x minus 4 is 0. X is 4. So I know then the point of intersection for those 2 lines is 4, 1. Now what I do is substitute this into the third equation. If I substitute this into here and it works, then I've got 3 concurrent lines. They all meet at that same point. So let's do that. I've got 3 times 4 plus 2 times 1, take with 14. I hope that equals 0. So 3 4s are 12, plus 2, take with 14, equals 0. 12 plus 2 is 14, minus 14, 0. Excellent. I've got 0 equals 0. Great. All 3 of them intersect at that point. So then we say, therefore, the 3 lines are concurrent, and they meet at this point. So they meet at 4, 1. That's the point of intersection of all 3 lines. So it's like that when we're proving them. We have to take 2 of them, work it through, and then the third. Remember, like I said here, don't substitute into the third at this point, because that's an assumption, not a proof. You're assuming it works at that point, not proving it. Another example for you is the following group of lines concurrent. So I've got 3 equations here. I need to be able to solve them, get a point, and then substitute it into the third. Now again, you pick any pair you want. solve those, and then use the third one. I'm going to pick this one here and this one here. They would be the easiest pair to solve in my opinion, but it doesn't matter what pair you pick. Just as long as you pick any two that you want to work with, just make it easy for yourself. So I've got y equals 2x plus 5, y equals 3x minus 1, set them equal to each other. So 3x minus 1 equals 2x plus 5. I know it's y equals and y equals here, so I can do that. Shift things about and solve, I then get x equal to 6. What I can then do is put it into one of these two equations again. Again, don't put it into the third one because you're assuming it works, not proving it. If I put it into here, I get y equals 2 times x, so 2 6's, which is 12, plus 5, which is 17. So the point of intersection of those two lines is 6, 17. So if I now substitute it into this one, and it works, all three of them meet at this point, so they're concurrent. So let's try it. So 17 equals a half times 6 plus 8. So 17 equals, well, half of 6 is 3, plus 8 is 11. Oh, hold on a second. 17 doesn't equal 11. What that then means is they're not concurrent. They don't all meet at that same point of 6, 17. They're not concurrent, so all three of them won't intersect at the same point. So this will be one of the scenarios where we introduce where it looks something along those lines. They'll meet each other, but they won't meet as a group together at one singular point. When we're proving lines are concurrent, this is what we have to remember. This is how we prove it. Take a pair, solve them, substitute into the third. And again, remember, make it easy for yourself. Pick the easiest pair to solve and solve it using the technique that resonates and works best with you, whether that's simultaneous equations, substituting in, or setting them equal to each other.